All right, welcome to section 6.7. Today we're going to be talking about sums of arithmetic and geometric sequences. Before we start, we're going to go just review over some vocabulary from secondary 1, as well as new vocabulary that we're going to need to know for this year. And this is on page 330 of your workbook. So when I go to page 330 of my workbook, we have for our vocabulary box, I'm just going to focus on for just a minute, the definition of a sequence, which is what you did last year. You had your first term a sub 1, your second term a sub 2, your third term a sub 3, a sub 4, and on it went. And it's a list of terms in a specified order where a of 1 is the first term and a of n is the nth term or the general term. A finite sequence is what we're going to be studying right now, has a first term and it also is going to have a last term. While an infinite series will have a first term, but then it will go on without end. Now today we're going to be looking at series, arithmetic and geometric series. A series is the sum of these terms of the sequence. A finite series sums the terms of a finite sequence, while an infinite series sums the terms of an infinite sequence. So today we'll look at the finite series, and then tomorrow as we analyze series we'll look at it if it was an infinite series, what it would look like. Now from last year you studied two different types of sequences. You studied what were called geometric sequences, and I don't know why they didn't bold that, but arithmetic sequences. A geometric series is the sum of the terms of a geometric sequence. So you have your summation or sum of a plus a times r plus a times r squared plus a times r cubed, etc. Now in secondary 1, we said, oh, this is the same thing as a sub n equals a sub 0 times r to the n. Right? That was our geometric. And this we had our a sub 0 was what it would be if our term was 0, or what it was at the beginning. And then our r was what it was multiplying by each time. An arithmetic sequence or series is an arithmetic sequence, and it's the sum of them. So it's your a plus d plus a plus 2d, a plus 3d, etc. So this is the geometric. And for arithmetic, notice this is the r, so that's the r, and then this one's the d. So it's a sub n equals, and it's kind of linear, a sub 0. And that was the big rock of last year, is that exponential function was a geometric series, and a linear equation was an arithmetic series. So this is the arithmetic. But now the new piece is we are going to put them into a special notation. We're going to use the Greek capital letter sigma. That's what it looks like, kind of a funky E, and it's going to be used to indicate the sum of the sequence. That's what it means. The sigma is followed by an explicit formula for this sequence. So it's going to look like one of these two, an explicit formula. The small number below the sigma is the first term, and that will always be k equals 1 for our sequence. Okay, it will always be k equals 1. So instead of n, we use k. And that will be considered the lower limit. And the smaller number above the sigma will be the last term, or the upper limit. Now when we go to write it in sigma notation, that's what it's going to look like. On our problems, we're not always going to start at 1. They'll have us start at a different piece in the series. But for when we write our final answer, this will always be a 1. This will be your upper limit, and then this is where you'll write your explicit formula. Okay, so that's kind of the basic ideas. Now what we're going to do is talk about what it means to write out and evaluate a sum. So back to our notes for right now, and then we'll go to our graphing calculator again in just a moment in our workbook. So they want us to write out and evaluate each sum, but notice it doesn't start at 1. It starts at 2, and they want us to stop at 6. So when I go to write it out, this is what it's going to look like. I'm going to have 3 times 2 plus 1. That's 1. And then I'll do 3 times, then the next one in the series would be a 3 plus 1. That in parentheses so it doesn't confuse us. Plus 3 times 4 plus 1. Plus 3 times 5 plus 1. And then I'm going to end at 6, so plus 3 times 6 plus 1. Now for this particular problem, I probably can do it faster brain-powered than I can calculator-powered, although you're more than welcome to just type that all into your calculator. This one happens to be an arithmetic sequence because it's in that form. dn plus a sub 0. 3 times 2 is 6 plus 1 is 7. 3 times 3 is 9 plus 1 is 10. 3 times 4 is 12 plus 1 is 13. 3 times 5 is 15 plus 1 is 16. 3 times 6 is 18 plus 1 is 19. 7 and 10 is 17 plus 13 is 30. This makes 35, so total answer is 65. And again, I did that really quickly, but you're more than welcome to go and just punch that all into your calculator. But you do have to write it out. Okay, you do need to write it out. This next one, notice that the k is in the exponent, so that means it's an exponential function, which means that it's a geometric series. So this one, when I go to do the summation, again, it starts at 2, so I'll have 3 to the second, and then I'll do 3 to the third, I'll do 3 to the fourth, 3 to the fifth, and then I'll stop. So again, I'll use my calculator. I'm just going to use my graphing calculator today so I don't have to go back and forth between them. So I'm going to have 3 squared. You should have done that in the head. 3 cubed plus, oops, cursor over, I don't need that little plus there. Plus 3 to the fourth, plus 3 to the fifth. And I get 360. And on your first part of your assignment, that's what you're going to do, is you're just going to do the summations. You're just going to practice them a couple of times, writing them out. Well, that's just fine and dandy if it's only like 4 or 5 terms that you have to add up. But what happens if I have 15 terms? Well, actually 16, from 5 to 20. Well, I don't want to have to do that, writing it out and evaluating. So we're going to use our calculator, and we're going to go to page 331 and 332. Now, this is what our workbook says to do, and then I'm going to also show you a different way to do it as well. So on page 331, at the bottom, here's where it starts to say the steps. So I'll get my graphing calculator out. It says the first thing I need to do is press second stat, and then I go over to the math menu and choose option 5. So cursor over to math. If I look at option 5, it's the sum, which means the summation. So there we go. Turn the page. Then I have to do second stat again. So cut that into and put that on my screen. It says that so far. Zoom this down a little bit. Then it says press second stat again. But this time you're going to use the ops menu, which means options menu, and we're doing a sequence. So I'll choose number 5. So then number 5, and that will tell you the sequence. And then here's what you're going to have to type. So notice that's what they've got right here. Summation of the sequence, and then we have 2x minus 3. You have to type this, then you have to do a comma, then x, then a comma, then 5, then a comma, then 20, then a comma, and then close it out. So it looks like this. 2x minus 3, the comma is right here, right above the 7, then the x, a comma again. It starts at 5, comma, ends at 20, close it out, and my answer is 352. Let's do D. Let's do an exponential. So again, it's second stat over to math, 5, second stat over to ops, put 5 again, and this time I'll have -2, then parentheses 1/2. So to do 1/2, I do 1 divided by 2, close the parenthesis, then I need it to be an x up in the exponent, cursor over, then I need a comma, and it's going from 1, comma, to 8. Close my parenthesis. Oops, I have an error somewhere. Oh, I forgot what I always forget, and that is I forgot my x. Then the comma, exactly what I told you don't forget. 1, then the comma, then the 8. If you forget the x, then it won't do it for you. Now that is a crazy decimal, so I would ask you to have all your answers be fractions. So, and we're going to need that for the next unit that we go to, or next section. So remember, you press math, which is right here, and then press enter, and then it will change it to a fraction, negative 255 over 128. Okay, we want to have fraction answers. Now, that's the way the workbook says to do it. Now I'm going to show you one more way to do it, and it's much faster. I don't have to remember that whole x comma, then the lower limit and the upper limit, and I find it in the math section. So you go to math, and then it's option 0. So cursor all the way down so you can see it. And then if you notice, 0 is summation, and it even's got the cool little summation button right there. So you just press enter, and then you just fill in all the pieces. So blank equals, so you'll put your x equals 4, we'll do b, and then you'll have to cursor up to get up to here, 42, and then you'll have to cursor right to get into there, and type negative 4x plus 5. That is so much faster than everything that we just did, but it will still give you the same answer, which is negative 3,093. So you can decide which of those options you want to use, whether you just go use this piece or whether you follow the directions using the second stat 5 and then second stat, go over to ops 5 and enter it in. This is a lot less button pushing. I'm not quite sure why they didn't put that into our workbook. All right, so hopefully you've tried the last one. Again, remember it was math, 0, x, cursor, oh, it already gave it to me, equals 1. Upper limit is 5. Explicit equation is negative 5, parenthesis 2, close the parenthesis, raised to the x. Press enter, and it's negative 310. Okay, that's the second part of your assignment. Last part of your assignment is that you have to write a series using sigma notation. Well, before you can write your series, you first have to identify what kind of series it is, whether it's arithmetic or geometric. So I'm just going to kind of write some information just over here on the side, and then we'll just kind of circle it. If it's arithmetic, then it will be for the explicit equation, which we wrote this in our notes as well, a sub n equals dn plus a sub 0. If you can figure out how to do your a sub 0, most of you can just logically see it, but your a sub 0 will be equal to your a sub 1 minus d. And this is all review from last year. If it's geometric, meaning that they're multiplying, then your explicit equation will be a sub n equals a sub 0 and then r to the n. If you can't logically see what a sub 0 is, you can find a sub 0 by doing your a sub 1 and dividing it by r. And if you can't figure out what r is a sub 2 divided by a sub 1. But again, most of you will be able to just logically see those pieces, but this is how we find our a sub 0 and our r. Okay, I think we're ready to go. So, example 3, the last part of your assignment. So I look at the, excuse me, I look at this series and I've got 3, 6, 9, and then it ends at 24. So it looks like they're adding 3 each time, so that means that it's arithmetic. If it's arithmetic, that means that it's d equals 3. Excuse me, I have a frog. A sub 0 would be what would come before it. Well, if they're adding 3, if I go back in time, that means that's going to be a 0. So my explicit equation would be a sub n equals 3n. You could put plus 0 if you wanted. Now they want my series to stop at 24. So that means that right here it has to stop at 24. So I'm going to have 24 equals, this is like my a sub n, it's going to come right here, equals 3n. And so n is equal to 8. So I've got all the information that I need to fill this in. So here's our first time writing our sigma. There you go. Remember, it's about k now. And you'll always start at the first term, so k equals 1. And now we found out that our series ended at 8, the 8th term. So we'll put 8 right here. And then we'll just write this explicit equation, except don't use n, make sure you use k. So 3k. And there you go. I'm going to do D next, and I'm going to ask you to try B and C by yourself, and then we'll go back and correct B and C as well. So on D, it's going 5/4, 5/8, 5/16, 5/64. So this one is an example of a geometric. So if it's geometric, that means it's going to have an R, and I'm going to need to know my a sub 0, and then I'll write my explicit. So it's multiplying, it's staying 5, so that means they're multiplying by 1 in the numerator, and then it's going 4, 8, 16, 64, so that means they're multiplying by 2. So R is 1/2. So if I go back in time, I have 5/4 and I need to divide it by 1/2. Well, this would still stay a 5, and this 4 would be a 2. So that means my explicit equation would be a sub n equals a sub 0, which is 5/2, times r, which is 1/2 to the n. But remember, it's ending at 5/64. So I have 5/64 equals 5/2 times 1/2 to the n. And I'm just going to have to do some computation here for a minute to figure out my n. So first I need to get rid of the 5/2. So to do that, I'm going to times by 2/5. It's the easiest way. You could divide by 5/2, but it's easier if I just go with 2/5 like this. So the 5s will cross off, and 2 will go into 64/32. So I have 1/32 equals 1/2 to the n. So the 1 is staying to 1, so I'm really just focusing on 2 to the what gives me to 32. 2 to the what power. So you just have to do a trial and error to start guessing. Maybe you want to try like 2 to the 3rd. Well, hopefully most of you know that 2 to the 3rd is not going to be it. 2 to the 3rd is 8. 2 to the 4th, 16. 2 to the 5th, 32. So that means that n equals 5, or my upper limit is 5. 1/2 to the 5th power would be 1 to the 5th would be 1, and 2 to the 5th would be the 32 in the denominator. Okay, so I'm ready to write my summation then. So I write my sigma. K is equal to 1, and it ended at 5. And then my equation is, my explicit is right here, 5/2 times 1/2 to the k. Oops. All right, if you'll please try B and C by yourself, and then, so pause the video, and then turn it back on when you're ready to see if you got B and C correct. So B is another arithmetic. They're subtracting 3 each time. So D is going to be -3. My a sub 0, well, if they're subtracting 3, then going back in time will make it 15. So my explicit will be -3n plus 15. That's what a sub n equals, but I'll need to put -15 in for my a sub n. And minus 15 gives me -3n, or -30 equals -3n, so n, kind of run out of room, is 10. Now your n should always be an integer, and it should be positive. If it's not, then that's kind of self-checking. That's letting you know that you've made a mistake. So now I'm ready to write my sigma, my series using sigma notation. Went from k equals 1, it stopped at 10, and it's -3n plus 15. So when I go to C, looks like they're multiplying, so this is geometric. So R looks like they're timesing by 4. My a sub 0 of 4 divided by 4 would make that a 1. So that's 16,384. That's, instead of a sub n, I'm just going to write that there, equals 1 times 4 to the n. Well, dividing by 1 is just going to get rid of that. So 4 to the something is 16,000. Well, let's try, what should we try? 4 to the 5th? No. 4 to the 7th? There it is. So n is equal to 7. So summation, k is equal to 1. It stops at 7. I can put the 1 if I want, like this. 4 to the, oh, I just realized I made a mistake up here. This should have been a k. This needs to be a k. Or you don't even really need to have that 1 if you don't want it. All right, guys, so just be careful. Make sure you have the k's there. You're going to have those 3 different examples. Make sure on the first part that you write it out. They're not going to be too long. They're not going to be too crazy, but write it out and then get your answer. You definitely could go use your calculator when you're done and check to make sure your answer's correct. Then use your calculator either using the directions from page 331 or use that cool shortcut button, and then write your series using sigma notation. Decide whether it's arithmetic or geometric, and then solve from there. Good luck and enjoy.